today we're going to be testing the bolt's radiated emissions. These tests measure how much electromagnetic energy the bolt emits at certain frequencies, and there are limits for this for the FCC and also for worldwide standards. This set of equipment is designed for these tests that we'll be conducting over the next several days. The spectrum analyzer and EMC analyzer can measure very precisely the amount of emissions that are coming out of the bolt. We have other equipment that will measure the bolt's immunity to RF fields that we'll do in the next few days. We have the bolt inside our screen room. These emission limits are very small. So to make precise measurements, we have to have the bolt inside an RF shielded room. So this screen room is designed as a Faraday cage, and it prevents outside EM fields from coming in and prevents anything in here from getting out. So this is an RF quiet room so that we can measure just the emissions from the bolt and nothing else in the environment. So we have the bolt as the device under test, and we had, for the first set of tests, a biconical antenna, which is rated for 30 to 300 megahertz for this first series of tests. And in the screen room, we have copper shielding to prevent any other noise from getting in, and also RAM material to prevent reflection. So we have a more accurate test. And we have an isolated feed through to supply AC power to the bolt within the room, and this AC power is filtered as part of the screen room environment. So we're powering the bolt up, and we are going to measure its emissions first for the low frequency band of 30 megahertz to 300 megahertz. So we'll come over and we'll close the screen room door. And now with the door closed, that's an isolated environment, and that biconical antenna comes through the feed-through port into the spectrum analyzer. And we will turn on the continuous sweep. And here, the spectrum analyzer is showing the equivalent volts per meter field. We're showing the CISPR 22 limit, which is very similar to the FCC Part 15 Class B limit, which is very low. That's designed for consumer electronics. The bolt actually would be a Class A device, which has more relaxed limits, but we're going to test the more strict limits to see what we get. So here we have a limit, it's roughly 40 microvolts per meter equivalent field, and the spectrum analyzer has the calibration coefficients for that antenna to convert the received voltage into a field strength measure. And we're using a 3 kilohertz resolution bandwidth here, and you can see with the sweep that the volt is underneath the limit. We have sweep from 30 megahertz to 300 megahertz, and this is a 10 decibel per division, actually 5 dB per division scale, and we can see we're at least 15 dB underneath the limit at 30 megahertz. This 40 megahertz component is the volt power supply from the switching power supply in the bolt, but it's still well within the limit, 15 dB underneath the limit. And then as we go up in frequency, these small spikes are digital emissions from the bolt, and it is well underneath the limit up to 300 megahertz. So the bolt has passed the first set of radiated limits, the 30 to 300 megahertz limit, in accordance with FCC Part 15 Class B and CISPR 22 limits. Now we're going to complete the radiated emissions test for the bolt. We are now going to test from 300 megahertz to a gigahertz. And to do that, we have a different antenna. So inside the screen room, we've swapped out the biconical antenna for a log periodic antenna. And this antenna is designed for EMC tests from 300 megahertz to a gigahertz. And the antenna is pointed directly at the bolt, the device under test, and the bolt is already powered through the coupling port inside the screen room that allows 120 volts to come into the screen room. Now the bolt's powered, we begin to sweep. And we are sweeping from 300 megahertz to 1 gigahertz, and this white reference line is the limit of the frequency per CISPR 22, also in harmony with FCC Part 15 emissions limits in this range. And we can see that the bolt is underneath the limit over the entire range. And so the bolt has passed the emissions limits from 30 megahertz to 300 megahertz with the other antenna. And then in this test, we completed the emissions testing up to a gigahertz, and the volt just passed both.